Now that we have discussed about curved surface area of a cone, now let's see what happens if I add the base, which is a circle, to the curved surface area. Obviously, we get the total surface area. The curved region and the base add up to form a total surface area of the cone. This session is about total surface area of a cone. So let's take a cone. We have the radius and the height and the slant height. So let's see what is the total surface area of this cone. So clearly, the total surface area of a cone is nothing but the curved surface plus the circle, is curved surface area plus area of circle, which is obviously the bottom. So here we have already derived for curved surface area in the previous session of the cone to be pi RL. And area of circle we all know is pi r squared, which r is the radius and the base is the circle. So taking common, I can remodify this as pi r into r plus L or L plus r is how I get total surface area of a cone. Therefore, total surface area of a cone with radius r and slant height L is given by pi r into r plus L. Total surface area of a cone is pi r into r plus L unit square. Now that we have discussed about a cone or a right circular cone with its curved surface area and total surface area, now let's find what important relation between the radius, height and slant height of a cone. This session is about relation between r, h and L. Radius, height and slant height of cone. Radius, height and slant height of cone. So here I have the radius, here I have the height, and here I have the slant height. And of course, this is a right circular cylinder, so this is 90 degrees. Now clearly I see that this OAB forms a right angled triangle. As can be seen here, OAB forms a right angled triangle, OAB. Now in this case, OA is radius, this is height, and this is slant height. We clearly see that this is a right angled triangle, so the first thing which strikes my mind is Pythagoras Theorem, of course. So in triangle or in right angled triangle OAB, if I use Pythagoras Theorem, AB squared, that is hypotenuse squared, is OA squared plus OB squared by Pythagoras Theorem. That implies AB, which is L, makes out to L square, which is OA, which is R square, plus OB, which is H square. So here the relation between L, R and H is L is root R square plus H square, or L square is R square plus H square. The radius, height and slant height of the cone are related with L square equals R square plus H square. R, L and H of the cone connected with this equals this. Now that we have discussed about cylinder and a cone, now the next solid object which we are going to define in the topic is sphere. This session is about sphere as a specific solid object in 3D. What is a sphere? How does it look like? Imagine I take a football or a basketball. So assuming this to be a basketball, the kind of a shape which it looks circular in all directions is called a sphere. So a basketball is the shape of a sphere. But how do we define a sphere in general sense of understanding through mathematics? As we have seen different shapes, like a basketball which looks like a sphere, a cricket ball which looks like a sphere, a football which looks even like a sphere, a football which looks like a sphere, a cricket ball which looks like a sphere, a basketball which looks like a sphere, the sun which also looks like a sphere when seen, is all what we have different objects which look like a sphere. But what is the sphere? How do we understand through mathematics? Is what we are going to see in the next session. Now let's define sphere in more mathematical means. Sphere with its definition. A sphere is the set of points in space. Importantly to note, in space, a sphere is the set of points in space which are equidistant from a fixed point. That's how we understand a sphere. So set of points which are taken in the space are equidistant from a fixed point. That is, when I take the fixed point in the center and spread all the points which are equidistant, then I get a three-dimensional object which is a sphere. And the distance from center to this is called radius, and this fixed point is called center of sphere. So here the fixed point is called center, and the distance from fixed point to any point on the set of points is called radius. Is how we understand a sphere whose radius and fixed point define a sphere. Set of points in the plane which are equidistant from a fixed point is called a sphere. Now that we have defined a circle, So a sphere in mode of three-dimensional object. Let's see what could be the curved surface area of a sphere. This session is about curved surface area of a sphere, or we can simply call this as surface area of a sphere because every corner of the sphere is curved. So this can also be referred to as surface area of a sphere. So a sphere which has the radius r. So this sphere which has the radius r is given by surface area of sphere is given by 4 pi r squared. That's how we understand the surface area of sphere is 4 pi r squared. R is radius of the sphere. Now that we have discussed about sphere, let's try to see what would happen if I cut the sphere exactly at the center. So imagine I have a sphere which is cut exactly at the center. So I cut the sphere exactly at the center in this region, then I get two separate regions. Which are separated like this. So we have two different shells which are obtained when I cut the sphere exactly in the center. Each of the shell is called hemisphere. This session is about discussion of hemisphere. So each of them are called hemispheres. So let's define the surface area of a hemisphere. Now this is the curved region which defines for the surface area. So the curved surface area and if this circle is added up to this dotted region, then that becomes total surface area. So curved surface area is the dotted region and the total surface area is both the dotted region and the curved region. So this is how we differentiate between the curved surface area as denoted by the dotted region is the only curved part of the hemisphere, and total surface area which includes the bottom and also the top of the hemisphere is how we are going to discuss the formulae for curved surface area and total surface area of a hemisphere in the following session. Now let's see the curved surface area of a hemisphere. I have a hemisphere in which curved surface area of hemisphere as denoted by the dotted region as given here is given by 2 pi r squared, where r is the radius of the sphere. R is the radius of the sphere. Curved surface area of hemisphere is 2 pi r square. Let's see the total surface area. Now next comes the total surface area. Total surface area of hemisphere as given by the two regions. One is the dotted, one is this. Is curved surface area, which is the dotted, plus the total this area of circle, which is given by this region. So this represents CSA and this represents a circle. So area of circle. Now curved surface area is already found to be 2 pi r square. And area of circle, we all know, is pi r square. Therefore, 2 pi r square plus pi r square is 3 pi r square. This is nothing but the total surface area of the hemisphere. CSA 2 pi r square, TSA 3 pi r square for a hemisphere. In mathematics, volume is defined to be the capacity or the space which it occupies in the three-dimensional space. Suppose I take this marker pen, which looks like the shape of a cylinder. This seems to be occupying certain space in this area. And this space occupied is nothing but we define in mathematics as capacity or the volume of this object in the space. So let's see some volume formulae for the three-dimensional solid figures which I have discussed in the past sessions. To start with, cuboid. This session is about volume of a cuboid. What is the volume of a cuboid? Let's see the formula derived for a cuboid and its volume. I have a cuboid which looks the shape of a rectangular box. Now this is a rectangular box which is in the shape of a cuboid. We have its length, its width, and its height. A cuboid has three main important dimensions. One is the length, one is the width, and one is the height. And how do we find the volume of this cuboid? Is all based on the length, breadth, and height of the dimensions. So for this cuboid, volume of a cuboid is given by the formula LBH unit cube. So if I have the length, the width, and the height of the cuboid, I just multiply all the three dimensions, which gives me the volume of a cuboid. Is how I understand volume of a cuboid. For example, I have a cuboid with the dimensions 2, 3, and the width is 2 and the height is 4. Then having the length as 3, width as 2, and the height as 4, I have the volume of cuboid, which is given by the formula length into width into height, that is 3 times 2 times 4. Because my length is 3, width is 2, and height is 4, I get this to be 3 2 6, 6 4 24. And if the dimensions are centimeters, then all the dimensions give me the volume as centimeter cube. Is how I understand finding the volume of cuboid when its dimensions are given. Volume of a cuboid with the length L and the width B and the height h is given by the formula LBH unit cube. Now that we have discussed about a cuboid and its volume, now comes the discussion of volume of a cube. We all know that a cube is a special case of a cuboid where its length, width and height are of same dimensions. Therefore, let's see how the volume of a cube is derived using the concept of volume of a cuboid. I have my cube. Say its side is A, then all its dimensions are same. That means I understand that if this is a cube, then its length is A, width is A, and my height also is A. Therefore, my volume of a cube is LBH A times A times A. So I get the formula which says volume of a cube as a special case of a cuboid is LBH, but my L is A, width is A, and height is A, which gives me A cube. Therefore, volume of a cube is A cube unit cube. That's how we get. So if you know the side of a cube, just cube it and we get the volume of the entire cube. Is how we understand the volume of a cube, understood through the formula of cuboid. Volume of a cube is A cube unit cube. So for example, if I take a cube of side 2 dimensions or 2 meters, then volume of this cube whose dimension is 2 meters is given by 2 cube, because we have the formula A cube with A equal to 2. I have this 2 cube which is 2 times 2 times 2 and 8 meter cube. Is how we understand the volume of the cube given its dimension. Is given by the formula A cube unit cube, where A is the side of the cube. Now that we have discussed about a cuboid and a cube with their respective volume formulae, now comes the question of what could be the volume of a cylinder. This is the shape of a cylinder and I would like to know what is its volume. So let's see in brief in this session about volume of a cylinder. We all know that a cylinder is in the shape like this, and we know that for this cylinder we have the radius which is denoted by R and the height which is denoted by H. So here is the radius of the cylinder and here is the height of the cylinder. So let's see what is the volume of cylinder based on radius and height. So here the radius and the height of the cylinder define the volume. Volume of cylinder is given by pi r square h unit cube, is what we have as the formula. Volume of cylinder is pi r square h unit cube, where r is the radius and h is the height of the cylinder. So let's see how we can solve some example problems using this formula. For example, I have a cylinder whose radius is 3 centimeters and height is 4 centimeters. So I would like to just find for this formula. So in this case, volume of given cylinder is given by the formula as we're taken here, pi r square h. So pi and r square, we know that the radius here is 3 centimeters and the height h is 4 centimeters when compared with r and h of the given problem. So using this r and h into the formula, I get r square into h. And this, on further simplification, gives 3 3s 9, 9 4s 36 pi centimeter cube. So volume of the given cylinder with radius 3 centimeter and height 4 centimeters is 36 pi centimeter cube, using strictly the formula out here. Therefore, volume of cylinder is given by the formula pi r square h unit cube. Now that we have discussed about a cylinder and its volume, now comes the next question: what could be the volume of a cone? In similar manner, in this session, let's see how we can derive the formula for volume of a cone. We all know that a cone has its own shape. So taking the shape of a cone, which looks somewhat like this, and then fixing from here, from the center, this distance is called radius and this distance is called height. So in a cone, we define this to be radius and this to be height. And using the dimensions of radius and height, of course, we have a slant height denoted by L. So by using the dimensions of R, H and L, we can define the volume of a cone, which is given by the formula volume of a cone is 1 by 3 pi r square h unit cube. Is how I get the formula. Volume of a cone is given by 1/3 pi r square h. Note, it's a very important note I make here, that volume of cone is 1/3 of the volume of cylinder from which it is derived. This is very important to understand because we understand a cone being generated from a cylinder. So volume of a cone is always 1/3 of the volume of the cylinder, which you already discussed in the previous session as pi r square h. So 1/3 of volume of cylinder from which it is derived. What do we mean by from which it is derived? For example, I take a cylinder Imagine I cut the cylinder exactly from center. So that I get something like this. So we assume that if a cylinder is cut into 3 parts, part 1, part 2 and part 3, this clearly is said to be a cone which is generated from this cylinder, and hence a cone generated from a cylinder is 1/3 part of the entire cylinder, and hence volume of a cone is 1/3 of the volume of cylinder from which it is derived. Cut the cone, you get 3 equal parts, and hence this volume of a cone would be exactly 1/3 of the entire cylinder. Covering part 1, part 2 and part 3 is how we understand a very important geometrical concept connecting cylinder and a cone, given by this relation. Volume of a cone is 1/3 pi r square h, where r is the radius and h is the height of the cone. Now that we have discussed about a cylinder and a cone, now the last geometrical structure, solid figure, which we're going to discuss now is about a sphere. What would be the volume of a sphere is what is today's session. So let's see what could be the volume of a sphere. Imagine I take a sphere, which is this, and say the radius of the sphere is, say, r, capital R. If the radius of the sphere is r, then the whole of the volume is based on the radius. So here we have a formula which says volume of a sphere is given by 4/3 pi r cube unit cube. Volume of a sphere is 4/3 pi r cube, is how we understand, with r being the radius. So with this, it's clearly understood that if the volume of a sphere is 4/3 pi r cube, then volume of a hemisphere is half of the volume of the sphere, that is 2/3 pi r cube unit cube, because exactly a hemisphere is nothing but half of the sphere. So we have this to be, this is the radius and this is the hemisphere, which has 2/3 pi r cube unit cube. Volume of a sphere is 4/3 pi r cube. Volume of a hemisphere, which is exactly half of the sphere, is 2/3 pi r cube unit cube, where r is the radius of the sphere. Let's see some example problem to understand the concept more stronger. For example, I have a sphere whose radius is say 3 centimeters. Let's see what could be, whose radius is say 3 meters. Then volume of the given sphere, whose radius is given to be 3 meters, is clearly given by the formula 4/3 pi r cube. So 4/3 pi r cube, which is substituted with the value of the radius r. This gives me 3 squared 9 9 fours 36 pi meter cube, is how we understand the volume of the sphere with radius 3 meters is 36 pi meter cube. Answer in terms of pi, using the formula 4/3 pi r cube. Volume of sphere and volume of hemisphere.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.